My name is Brandon Young. I'm doing quick intros. I lead up our ecosystem here at Tab9, which covers anything from great integrations with IDs across the world, fun work with Amazon and Google and Salesforce and otherwise, as well as helping out with all of our messaging and everything else. And I guess I'm your host for the day, so my job is to keep this entertaining and tell you where the bathrooms are, which you already know. But more importantly, on the lower part of your screen, there's a part that says Q&A. Please, in that, ask all your questions, because I'm going to be monitoring it and both pushing them to Iran throughout to keep on task, because I know where we're going. I'll know how to cover it. Also, Arthur, thank you for saying hi. You're showing us how this all works, which is great. Raghunath, if you have a question, your hand's up. Do you mind dropping it into the questions real quick, if it's something there? But we want to run the questions on the right-hand side. I will facilitate them, and then I'm also going to add a lot of links to that, because everyone in the world would like to have this recorded later for Giuseppe. Yes, it will be recorded. It will be one that you can share with all your best friends. It's where you guys can have, wine and cheese on Friday night and watch the webinar, because let's be honest, you're not going to, but it'd be really cool if you did. And if you do, let us know. But with that, sorry, all the fun. I appreciate you all spending time with us today. I'm going to turn it over to Iran, who is our CTO, co-founder, a professor up at Technion University, and going to give you a lot of background around how and why these models work. And one of the things is these are some really important trends. So framing on this, you should be coming to this with a question that says, what are these models doing? Is bigger better? What does specialization look like? And those are all questions that Iran's going to give you some context. We are going to speak about this very much around where Tab9 functions, which is in the AI for software development. So that's where these are going to be, although Iran can go anywhere he would like and has lots of other work. So I'll be quiet, roll over to Iran. I'm going to ask questions and we'll jump in from there. So thank you so much. Iran, it is yours for the time being till I interrupt you again.
Hi, everyone. Thanks, Brendan. Thank you for attending this webinar. I'm happy to answer your questions live, so please keep them coming. It will make it more interesting. I have the Q&A panel open next to me, and Brendan will help facilitate as well. All right, so I'd like to start by just going on some background and really what you should be aware of, that is in the coming decade, all software will be developed with the assistance of AI. So we are entering a world in which, your job as developers will be assisted heavily with AI throughout all the software development lifecycle. And even today, Tab9 is already generating 1.2%, more than 1% than the code in the world. And this is increasing all the time, improving all the time. So, over the next few years, we're likely to see much more code automatically generated, tests automatically generated, documentation automatically generated, and you will get AI assistant throughout the entire software development lifecycle, right? So really, there is going to be an AI layer in any development organization, and this AI layer is going to support all of the SDLC stages, the code, the build, test, review, and deploy. And if you'd like to think about it like a little more concretely, there are a bunch of tasks that you're doing today, such as, let's say test generation, or maybe auto-fixing build errors, or code review, remediation of code review comments, or I don't know, anything around refactoring. All of these are going to get massive assistance from AI to the point that a lot of them are going to be completely automated, at least for the mundane parts of the job. So, automatic remediation of code review comments. If the code review comment is simple enough, I don't know, you should make the variable names more descriptive or something like that. These are certainly things that will be completely automated. Emmanuel, we don't know how much code is kept for production because we don't track our users to that degree, respect the privacy of our users. We just know how much we generate. So just for context, you can kind of see a simple example here of Tab9 and how come Tab9 generates so much of the code in the world. I think most of you are probably familiar with how this stuff works. So here is Tab9 in VS Code. You write a comment in this case, and Tab9 contextualizes on the comment and generates this entire class here, the entire student class, including encryption, using SHA-256, etc. Similarly, you can use Tab9 to also generate tests. So in this case, we have this find max function that iterates over an array. We can ask Tab9 to generate unit tests for that, and you can see that Tab9 generates both the kind of data for the test, the actual integers here, performs the computation, actually asserts the right thing at the end. And these are simple examples, and they can become obviously much more complicated. So just wanted to give you an impression of how that works. All right, so moving along, basically, if you're following the news around Gen AI, right, there's just so much going on. There are so many companies doing different things in different spaces. So there's obviously Tab9 here, but there's stuff around image generation, text generation, even stuff around video generation, speech, and others. So there's basically Gen AI over a huge range of domains, not just code. And all of them are basically, all of these companies or solutions behind the scenes are powered by large language models, right? So large language models are, to a large, at least the ones that I will talk about today, are transformer-based models. And the main thing that they do is reason about sequences. So they have no idea what the sequence contains for the model itself. It is just reasoning over sequences of integers, and it uses an attention mechanism to learn relationships between entities in the sequence. So the way these models work is that they get some sequence, and they're able to say, kind of learn how different words or tokens in the sequence relate to one another, what are the relationships between different things in the sequence, and use that to predict the rest of the sequence, or the future of the sequence, by learning the relationships between sequences. And one of the interesting things about transformer models or transform-based models is the emergent abilities. And these are things that kind of present themselves as the models grow in size. So it seems like you take these models, and basically they're based on transformer blocks that are just stacked over one another for many, many, many layers, as many as you want, actually. And it turns out that as you increase the model size, this greatly improves the performance of the model. And in fact, some abilities that are not present in smaller models become possible when models pass a certain scale. So if you look at the results of the paper on emergent abilities, the paper that looked at emergent abilities, and since then there has been some progress or some claims that what this paper is measuring is not exactly emergent abilities, but I will not go into that. If you will look at it as it was presented originally, what you see in this chart is a bunch of graphs which represent the performance or accuracy of the model as a function of its size. So let's pick one of them, say truthful QA here. What you see in truthful QA, the y-axis is the accuracy, so higher is better. And the x-axis here is the size of the model in terms of parameters. So you can see basically that as you increase the model size, the performance remains the same, but at some point, once you reach some critical size, in this case around, 10 billion, you see that the model starts to perform much better, right? So kind of as you increase the model size, suddenly something changes and the model ability become much better. And you can see that this is happening across many, many tasks. So this model was not trained specifically to handle truthful QA, like to answer questions without picking up on bias from small number of examples, which is what the truthful QA benchmark does. But once you reach a certain size, bam, performance goes up. And you can see this kind of behavior across many, many tasks that once you reach a certain size, the model kind of present this emergent ability suddenly kind of out of the blue. And the size threshold changes from task to task, but all of them, there's this shape of running flat for a while and then getting this linear increase in performance together with the increase of model size. All right, so this is kind of the emergent abilities, and this has led, not necessarily this, but in general, people have looked at larger and larger language model, and this is just a map of language model sizes up to end of last year, and this is a partial list. This is not all of the LLMs out there, but you can see that LLMs that have started, say, with GPT-2, maybe being a notable one, with around 1.5 billion parameters. And these days we're looking at things like Palm or Palm V2 from Google, which have over 540 billion parameters, or OPT that has 175 billion parameters. So we're definitely in the hundreds of billions parameters realm. Some of them are open source, some of them are closed source, but definitely have gone from single digit billion all the way to 3-digit billion of parameters, and actually going also above that as well. And so you can another view of this, which I like from the paper that you have the link to here on the left, is the evolutionary tree of models. So you can see how we started with things like whatever it is, like T5 or something, and have gone all the way to much larger models in 2023, and this is same goes like for going from GPT-2, which, as I said, is like 1.5 billion parameters, all the way to GPT-4 or GPT-3, somewhere on this tree, which I don't see right now, which is in the realm of 175 billion parameters. So really, over time, my point is that we've gone like from, say, 1.5 billion parameters all the way to 540 billion parameters and beyond, right? So this is increasing all the time.
Ron, while you're going through this, just if you could interlace, because we're seeing quite a few questions that are,
sure.
You and I always try to, you don't need to read the questions. I mean, you can, of course, because, hey, great. You can read, as it turns out, just so you all know, Ron can read. I know that probably a surprise, but hey, at least good news to start. The question I think that comes up is, you and I always chat about this. There's the UI UX, which is, front end of tab 9. There's the models, which we're talking about. There's the data. We're hearing a lot of questions around how the model and the data and the implications between the model and the data. And just useful if maybe while you're going through this, if you could interlace some of those trade-offs of what data it's trained on, how much data, how it gets incorporated, just some basics of how these models have been created and what the implications of the data sets are. Because I think the model by itself is kind of one piece, but I feel like we always have we're having all these conversations on how the two fit together. So feel free to keep moving, but I think that's a theme I'm seeing.
Yeah. Thanks for that, Brendan. I think maybe I should take the time to comment on that right now. Basically, as the model grows, you need more data to train it to kind of some convergence to some point in which it is has seen enough to kind of stabilize its parameters. So it is well known there are some scaling laws. There are some let's call them, in lack of a better name, back of the envelope calculations on how much data you have to show each model, like speculatively at least, to make it converge. And obviously, as the model grows, you need to show it more data. As you show it more data, it becomes a bottleneck of where do you get the training data from. And therefore, a lot of the larger models have been basically trained on anything you can put your hands on, which means like internet pages, right? Any kind of web crawl database, all of GitHub, regardless of licenses, of open source licenses, whether they're GPL or not, because you just need to throw everything you've got into the model just to feed it with enough data. And, you know, recently people have also been looking at transcriptions of YouTube videos just as additional sources of data, because you've basically consumed all the text on the internet and you need more text. So one way to get that is basically transcribe using AI, of course, transcribe YouTube videos that will give you more text to train on. So this is definitely definitely
So am I understanding this right? Like, Iran, it's when we talk about larger models, there's two implications. Not only are they larger, but it also just means like it's usually because it's so big, it needs so much data that there's a lack of discernment, maybe one way of saying it. I'm going to put words in your mouth, so feel free. By the way, so everyone know, I'm more of a salesperson, so I may be a little bit more. Iran will hold us very clear, but is that a fair implication to say, hey, it's great you say it's bigger, but bigger requires more data, and that data at some point it's just, again, grab anything I can possibly get to put into it.
I think that's fair. Like, bigger means require more data. At some point, data becomes the bottleneck. How do you get data with clear provenance that you have not thrown into the model? Things that should not be there is always a challenge and becomes much bigger of a challenge as the model grows. So yeah, so thank you for that, Brendan. And that actually leads me to my next slide, which is like, okay, so, you know, all these models are getting bigger and bigger all the time, right? As I showed you. And as you are going to like things of 530, 540 billion parameters, training becomes a real issue. And I will not kind of try to explain what petaflops here mean. It's relevant. I think I can simplify this slide by just saying that to train these things, you need millions of dollars. So this is becoming kind of a bottleneck just in terms of the cost and the computation and the energy required to train these models. And also, to some degree at least, the inference is also becoming an issue in terms of performance and cost. So as these models grow, you obviously have to also pay more computationally for running the inference, right? So if you're doing inference of the 540 billion parameters, there's just some flops, some matrix multiplication, some computation that you have to run through that consumes certain energy and certain latency. And therefore, to the kind of basic question from the title of the webinar, are these models are going to get bigger and bigger? I think right now, the bottleneck for a lot of it is actually the inference time and the inference cost. So as you increase these things, you start paying hard cash that is significant on the inference and also growing latency. And so one approach to getting bigger models is what's called sparse models that have been like quite fashionable last year, although have not hit prime time yet. And these are models like switch transformers or GLAM from Google. And I will not get into like the exact numbers on these charts. I think maybe the top level message here is that these are models that all the models that I mentioned in previous slides here are models that in each inference, you basically exercise all the parameters. These are called like dense models. So intuitively, you know, it's a bunch of matrices, and in order to get the result, you have to multiply all matrices in the model throughout all the layers. And what the sparse models do instead is say, you know, you don't always have to use all the parameters of the model for every inference. So there's like, you can think of it as like routing on top of a bunch of smaller models that decides which part of the model to exercise on each inference or each query. And so when we say 1.6 trillion parameters, not all of them are exercised on every inference. In fact, it's typically, I don't know, it could be 128 what's called expert models that are much smaller, order of magnitude smaller. And one of them is being exercised, or a number of them are being exercised independently on each inference. So I think we'll be seeing more and more of those, but we will not be seeing dense models that are scaling to like beyond 1 trillion parameters, just because, again, inference costs and training costs are becoming prohibitive. But I want to kind of preface all of what I'm saying by kind of a grain of salt, in the sense that nobody knows what will happen these days, that things are moving so quickly that I can have this kind of nice chart and explaining why there will not be 1 trillion parameter dense models coming next week, and there could be one of 2 trillion parameters coming up tomorrow, right? So I don't know. This is kind of the commonly held view, is that for growing beyond 1 trillion parameters, we're going to start seeing sparse models. Maybe one thing that may change that is further improvements in hardware, which will kind of make inference costs and training costs lower.
Around two pieces, I'm just add some interlace a couple of questions here. One, for everyone's adoption, the key learning I would take away from what he just said is the way that most users currently consume large language models is through an API call. It's important to note that the API calls that you are taking are likely dramatically subsidized. So back to Iran's point, what you want to understand is how this applies is these very large models, obviously when an API call is monetized at some level, or not, maybe oftentimes it's given away free while these companies are growing it. Be aware, like that cost behind it may be subsidized, but at some point this is a little bit of like it's like Uber for all of us. Eventually you have to pay Uber the price of the person getting from point A to point B. So to Ron's point, we don't know where that goes. Like there's a bunch of moving levers here, like how efficient, et cetera, it goes. But today, be aware what your understanding of cost has not been shared with you and is probably dramatically different than what you think. It's dramatically higher. Ron, a little bit of question, feel free to feed this, but the ton of fun questions here.
Yeah, I saw one of them that I want to pick up, which is actually interested. It's anonymous, so I don't know who to relate it to, but what happens when future generations of models are trained on text generated by previous generations, which I think is a really nice question. And if you've seen the work by OpenAI on basically, what did they call it? I don't remember, fingerprinting generated GPT-4 ChatGPT output, this is exactly what they did it for. So there is a way to identify zero GPT or whatever it is called these days, to identify text generated by GPT-4 or GPT-3. And the reason that they have this fingerprinting is exactly to detect text on the internet that has been generated by the model, so we don't train on it in the next generation of models, because otherwise you are stuck in this feedback loop that you're training on stuff that you've generated yourself, which will not lead to improvement. So definitely, again, there is real hunger for training data, and this is also why people are going into transcription of YouTube videos and other means of getting more original text to train on. So I really like that question. Another question coming up here, is quantum computing going to have an impact on how far can LLMs go? I don't know, probably, but at this point it's still very early in quantum, so I don't know what the future holds for quantum here. So I cannot predict that, but it's an interesting question as well. Regarding the cost of fine-tuning is obviously cheaper when you're doing fine-tuning on this size of models. You typically do it with adapters. You don't really fine-tune the weights of the original model. The original model is kind of frozen, but you add kind of adapter layer, which are lower dimensionality, which are the ones that are being fine-tuned for a particular downstream task. So the cost of fine-tuning those is obviously much lower than getting the pre-trained model going. Yeah.
And Aran, one last piece on here. I think this ties to Igor's question of like recency of this. So the data that's in the model, for context for everyone on this, these large models typically are point in time. And so they will do a snapshot on a point in time. This does vary. I think it's probably fair to say, I think the difference, OpenAI and say Google are doing this bit different. Google has a lot of real-time data, is probably more current from what we've seen with like a Palm 2. But the question Igor's getting at is, I think I'd extrapolate, Igor, your question a little bit, which is, hey, when something new shows up, how do I get this to prompt, or how do I shift my responses to be to something, either new language, this could be a new version, it could be any of those. Aran, typically what's the best practices in doing that?
Yeah, so it's a hard question, Igor, because like, for example, if Python 4 came along tomorrow, as you said, there's not going to be any code out there using Python 4, and therefore the models will not be able to give you assistance in Python 4. So there's definitely some delay in the ability of the model to assist you with emerging languages or emerging concepts. And I think that unfortunately is kind of built into having significant or sufficient training data to move the needle. If you are, say, a Tab9 customer and you have your own internal data set in your own language, we can fine-tune our models to support that particular language, even if it does not exist in the kind of outside world, or if you have a significant, amount of training data on our imaginary Python 4, we can definitely adapt the models to do that. So, but
the place we've seen this most is things like, hey, a lot of people going, I got a lot of COBOL data. There's a lot of COBOL, but there's not much open source COBOL. So that is, Iran's like, I hate COBOL, so he could weigh back in on this, but
I have no, as I no opinion on COBOL. It's a fine language, just as the other ones. I don't mind. Yeah, so Ernst is asking about competition from Palm v2. So Palm v2 is a model. Tab9 is not a model. Tab9 is an application built on top of models. If we can leverage Palm v2 as part of what Tab9 is offering, we'll definitely do that. Tab9 models, the ones that we are using ourselves right now, have some guarantees. And for example, having been trained only on permissive open source code or open source code with permissive licenses, meaning Apache, MIT, BSD2, BSD3, and nothing beyond that. Once you move to like these huge Palm v2 style models or GPT-4 style models, there are basically no guarantees on what went into the model in terms of licenses. So there's just some trade-off there. For customers, who want to work without any guarantees, we can definitely leverage Palm v2 or otherwise. But you have to realize that the difference between a model and an actual application is huge. It's like you asking me, should I replace my Tesla and drive a new battery instead, right? So the battery is not the car, and as batteries improve, stuff around the batteries will improve as well. But it's not a one-to-one kind of correspondence or replacement. Yeah.
Yep. Arad, let me combine Camilo's quick point, which is a great question. I apologize. We kind of jump in, and thank you for pulling us back up a little bit. When you talk inference is it's the serving of the model and the training of the model. So you have to train the model, and then that model itself has to be served. I'm going to tie this with the question Ernest, you asked. So serving that model, if it's a very large model, it has to sit on a very large amount of infrastructure, or perhaps a data center, right? GPT-4, for example, sounds like it sits on an entire data center. Palm 2 would do this. So understand there's a couple on the inference question. If you care or matter security, for example, to an enterprise, matters a lot, you will need to be able to run that model inside your VPC. you'll need to maybe run it perhaps oftentimes for maybe a large number of our customers or others with, say, I got to run it on my own hardware. You cannot run GPT-4 in your data center or in your VPC. That is an API call that all your data goes out to a large model and comes back. And there's implications to that. So trade-offs on this. So the inference question is what is the server, for the simplest of terms, think of like it's a server that gives you back the suggestions. You query it, gives back, query, comes back. That infrastructure, the inference, is what Iran was hitting on being, as they get bigger and bigger on the number of parameters, becomes something that requires an enormous amount of backend to both serve it and a cost per query. It's just a tree. Think like the number of times it goes down a tree. If your tree is big, it has to go on a bunch of different branches on the tree, and it's very expensive and it has to be on big infrastructure. So specialized models have a lot of pluses because they're better on a use case. They will not be as useful like universally, right? So Iran, feel free to weigh in here, but I think what we're seeing, so as you all are coming to this area, oftentimes what is trying to be solved in like a chat GPT is I want one model. I have no idea what you're going to use it for. So I want a huge model that answers all your questions. That's a reasonable thing to solve for. Obviously, we're talking code and specifically to also oftentimes customers with very specific code. Raghunath, you have very specific code. So I'll just leave this up here. Anyone that wants to participate in Raghunath's open source, like please help him. Raghunath, feel free to post. We love open source. So thank you for sharing and working with us. But you're getting to a much smaller use case. And that's where specific models and stuff that a Tab9 focuses on, that's code, versus a GPT-4 that's designed to write you Cardi B lyrics in the style of Shakespeare, which if you ask Tab9, unless Iran's changed something, we will be terrible at that use case.
Hey, we may be better than you think. Yeah, it's
please don't solve for that, Iran. You're trying to help me. I don't want to solve that problem.
It's an interesting question here from, again, some anonymous attendee of again, even if there is a reliable way to fingerprint generated text to avoid including it in training data in the future, wouldn't that drown out human created text in the future? I hope not. I definitely get your point. And I think there is a challenge there because the fingerprinting, once the human changed it even a bit, it is considered to be original text. So there's definitely going to be partially generated, partially edited text going into the training set of new models. But I think this is exactly why people are looking at, as I said, transcription of audio, transcription of video, etc., as new sources of original training data that has not been yet automatically generated. It will be, but not yet. So thank you for that question. That's a very good question. Yeah. Sorry. So let me try to make some progress. Igor, I'll get to your question in a second. I do want to
keep going, and I'll answer. Igor, I'll help on yours.
Yeah.
You keep running because we want to be conscious of we've got about 10 minutes. So let's keep doing
So I just want to give you some idea of what does it mean to use an LLM as a black box, and kind of what's the difference between an LLM and an application, what else goes into the mix here, right? So the model itself is something that takes an input sequence and gives you a predicted output sequence or output sequences. Right, but in reality, there's so much more going around the model itself. Like, for example, as you're entering the sequence into the model, you need to do all sorts of prompt engineering and hinting and context awareness. And as you're taking stuff out of the model, you also need to score the generated sequences and say which one is better. And you can do semantic filtering to make sure that the code that you generate actually makes sense and maybe compile or is at least syntactically correct. And you have all sorts of toxicity filtering and other sorts of filtering, making sure that what you get from the model is not hallucination and that it actually makes sense. All right. So for example, if we go to, say, some text model and say the fastest mammal is, the model can generate the answer, the cheetah, which can run speed of whatever, 75 miles per hour. And you can keep on doing examples like this, and you can ask the model, a brown horse is likely to run faster than, let's say, a white horse. That's like the green stuff is the stuff that the model generated. And it says brown horses typically have higher level of muscle mass and energy capacity, which means they can reach higher speeds than white horses. So I've looked at this example many times and I still don't know if it is correct or whether the model made stuff up, right? I'm pretty sure it's made up. If you ask it what's the tallest building in Paris, and I think this result I generated from ChatGPT this morning. So it says, as of my knowledge cutoff in September 21st, and this relates to earlier question about what is the cutoff point of models and what would they know. So the model says the tallest building in Paris is the Tour Montparnasse of 210 meters, and as far as I know, at least, Eiffel Tower is 330 meters, I think. So this is actually incorrect, but it is again said here or generated here with full confidence. And maybe my point here is that it's not clear that we can trust this kind of generation here. And again, more work other than just the model is required so we can trust the results. And so this is like the kind of problems with models become more apparent when you give it questions that have sharp or strong decision boundaries. For example, if we go to the LLM and ask it, a line parallel to this y equals 4x plus 6 passes through this point, and this is a very basic kind of linear algebra, linear math of, I don't know, like 7th grade, 6th grade. What is the y coordinate of the point where the line crosses the y-axis? Model generates this line crosses the y-axis at 0, which is unfortunately incorrect, right? So that's not great. And the question is, how can we help the model make more accurate predictions in these cases? And one of the ideas that if you take anything from this kind of webinar at a high level idea, technical ideas, I think that few shot prompting is definitely the idea to take away. And the idea is to help LLMs solve challenging problems by showing the model a few examples. So this does not require training the model and does not require changing the model weights. This just requires giving the right examples to the model. And this has been extremely successful in multiple, a wide range of domains, common sense reasoning, mathematical reasoning, and symbolic reasoning. And you have like the names of the papers here that you can look at later. But I'd like to give you an example for the kind of linear algebra problem that I just showed you. And the way that you do this for mathematical reasoning, just like the math question I asked you, is you give the model a prompt that is appropriate for the domain. In this case, we go for mathematical reasoning. So what we give the model as part of the prompt, as part of the input to the model, is pairs of problem and solution. And this problem and solution, as you can see here, they are written in some LaTeX form, which is a technical kind of form to write things. And you can also see that every example here in the solution ends with, I hope it is correct. You can see we give the problem, we give the solution, and in the example that we give the model, it always ends with, I hope it is correct. So we give the model all these examples as part of our prompt. So it's always problem, solution, problem, solution. And at the end of this bunch of examples, we add our own problem, which is the problem of the line parallel to this line here that passes through 5.10, and ask it what is the y coordinate. And now what happens is, because we showed the model all these examples of mathematical reasoning, the model now produces this solution. And these are actual things that I got from the model, right? So you can see that the model generates, since the line is parallel to this, the equation is this, where c is some constant, and since the line passes through this, we can substitute the values with this, and at the end it reaches the right solution, which is -10. And as you see, it ends with, I hope it is correct, just like all the examples that we showed in the prompt. So what happened here is that we gave the model a prompt of mathematical reasoning that made the model brought the model to the right area or the right mindset for answering our question. And also because in every solution, we kind of gave it not just the final solution, but also the kind of the way to get there. When it generated the result here, the green stuff that generated for us, it also generated kind of verbalized the way in which it reached the solution, which I think is kind of a generally interesting and cool thing to do. And again, if you're thinking about it from an application perspective, being able to provide this kind of the right prompt for the right problem in the right time is what part of what you have to do. People refer to that as prompt engineering, but it's more general that part of what you have to do in order to exercise the model correctly. Right, and you can go on and have more complicated examples around this, like you say, have some math word problem, and you can have the same kind of idea. The model gets this wrong initially, the math word problem, but if you give it like this chain of thought idea, you can make the model verbalize by showing it examples that break reasoning into steps. So the idea of chain of thought is to give the model examples in which you give it all the reasoning steps required to reach the solution. And when the model does the generation, it will also do kind of the chain of thought. It will also go through the exact steps of reasoning to explain why you reach a certain result. So again, if you go back and give a prompt that has these question and answers in which you have the exact kind of chain of thought or the reasoning, when you present it with a new problem that has a certain structure, it is able to again generate something that has the entire chain of thought or the reasoning sequence. And because you kind of guided the model to verbalize step by step, the model now reaches the right answer, which in this case is 9. I'd like to maybe go to one more thing, take one more minute of your time and say that chain of thought is not enough. And I'd like to present you with another kind of original idea, which was done by my former student, Uri Alon, who is a postdoc at CMU, which is program-aided language models. And the idea here is that instead of making the model generate the result, you make the model generate a program that when you run the program, it generates the result. So if you're giving a certain complicated word problems, as shown here, rather than trying to force the model to do all the computation in its head, so to speak, you basically tell the model, don't solve the problem, just generate a program for me that when this program is being executed, it will print the right result. And I think this is an interesting general idea of offloading some of the work from the model into another solver. So, the model teaching an LLM arithmetic sounds like a very silly thing to do. We know how to do arithmetic symbolically. We don't need to teach a language model to do 2 + 2. It's actually a very bad use of the power of the model. And this PAL idea, or program-aided language models, is one idea, but more generally, there's the tool former, which the idea here is that you teach the model how to use external tools, and the model learns to kind of run external tools rather than trying to do, for example, arithmetic calculation. It just learns to invoke a calculator in order to do that. So you teach the model to use external tools in order to offload some of the computation to things that are outside the model. Let me stop here because I'd like to kind of really finish this session of the webinar and maybe also answer some questions that we have here. So does chain of thought work for entirely novel class of mathematical or logical problems not found in training data? The answer is yes. It's a general idea. By forcing the model to kind of go through natural language and kind of explain the steps, what you're really doing is you're kind of helping the model verbalize the reasoning and therefore able to solve more problems in a reliable manner. So you're giving it some sort of a scratch pad to kind of express the thoughts and walk through the steps. And interestingly, it also helps with humans, right? When you go to your kids and they get the wrong answer, you can ask them, okay, now explain to me how you solve this step by step. And as they explain that, they actually get better at like finding their errors and also kind of more structured thinking, reaching the right conclusion. So I think it's a really general and nice idea. Somebody asked what.
Oh, go ahead, Ron. No, I think I just want to sort of, Ron, if there's anything last, I'll give you a sec to look across if there's any last questions. I want to say we're sort of hitting right end of time. So I want to sort of close a few things up. This is a system we're constantly going. You're going to get a follow-up email. I'm going to close in one last question and just verbalize it to everyone so you understand. The question was, what does Tab9 use under the hood? Is it based on GPT or PaLM? We originally leveraged GPT-2 back many years ago. We are regularly testing and training and building Tab9 against the best open source models on the planet. And we switch those out and our customers get that uplift, new innovation on a very regular basis. That's our strategy. And if along the lines there are better solutions, or as Ron highlighted in the case of PaLM 2 with Google, if that meets the requirements you have, you're okay with the data that's in it and you're okay with an API, we are working with Google on that as an option. There's always trade-offs. So particularly for the enterprise, we would love to chat with you. You will be getting an email from us. Please reach out. Happy to support you there. And if you're an individual user who want to play with it, Tab9, always sign up for all our free trials for Pro and everything. We'd love to have you use it anytime. So we appreciate all your time. Ron, any last questions you wanted to answer? Any pieces we should cover in the last 2 minutes?
Yeah, I just want to highlight, so it is clear that we're using GPT-based models that are own and range in number of parameters from, I think, 2.7 billion all the way to 15 billion. We're not using 175 billion parameter models because typically you don't need those for code generation, but we're always upgrading our models and that changes almost on a weekly basis. So thank you, everyone. I promised Igor that I will answer his questions. So let me, before we close, just say, is there a limit to the size of code that can be generated by a model? There's really no limit to kind of the size of code. I mean, there is a practical limit on the number of tokens that you can generate, but it can be thousands of lines of code, say. I think the limit is more on the human side of being able to consume what the model generates, because Igor, I doubt that you would like to read 2,000 lines of code automatically generated and review them for potentially subtle bugs that exist in there. So I think a lot of the challenge is around the UX and how humans can consume the generated code effectively. And I think that's a good comment to close on. In general, there is a lot to be done and improve on kind of the UX and how humans interact with products like Tab9. So thank you very much.
Hey, thank you all so very much for joining us and look forward. We will continue to run these. Let us know if you have any. You were easy to reach through our website. Again, if you'd love to use Tab9, thrilled. If this is a unit learning experience, happy we could help you. And if you're in an enterprise and need to adopt us in a secure way, we'd really love to talk to you, but that's for a subset of you. So you know how to reach us. We would be thrilled. Thank you for spending the time with us. Ron, thank you for lending us your brain for an hour. It helped me a ton, and I hope it helped everyone else.
My pleasure, guys. Thank you very much. Ciao for now.
Thanks all. Cheers.